Hello, this video is going to be on systems of equations. Maybe if I can click the right button, systems of equations. So let's start with again, systems of equations. It's chapter 4 in one of my textbooks, but it's in many of them. So you'll see this for lots of different ones. Okay, so the first thing I want you to notice is with these, I'm going to raise this up a little. There are actually 3 types of solutions, and I want you to see all 3 at the same time. Okay, there we go. That's good enough. All right, there's 3 types of solutions to a linear system of equations. Linear means they form lines when you graph them, and system means you have more than one. And these are possible solutions for those. So the first thing, if you think about 2 lines, they could be parallel. Although I should have used a ruler, mine don't look very parallel. If they are parallel, there is no solution because the solution is what they have in common. There's no points in common when they're parallel. So there'd be no solution. Then there's the case where you end up with all solutions in common, or they end up being one line. When you graph it. So you start with 2 equations, but you end up graphing them and they're like on top of each other. They're the same thing. So if that happens, then you have infinitely many solutions, and I can't spell infinite. And they're dependent and a consistent solution. So they still have answers. They just have lots of them, all of them in common. The last one is what we see the most. This is going to be one solution. X, Y, a point where they cross. So in this one, it would be over here. And they're consistent and they're an independent system. So this is kind of where you're at with systems of equations. So the first method or way that I want to look at these is called graphing to solve them, I guess. Graphing reminds you of how to graph, but graphing isn't the best way because you have to estimate where they cross. So that makes it a little more challenging. But let's look at my first example here. If I have 2 systems of equations, x plus y equals 5 and 2x minus y equals 4. So those are my 2 equations in my line. With those 2, I need to graph them and find where they cross by a graph. So I'm going to take the first equation and I'm going to make a chart. And remember, you just put any number you want in for x and find y. So I'm going to put in maybe 0. Well, 0 plus 5 would give you 0, or 0 plus what equals 5? Well, I can see that the answer has to be 5. So, hold on. I'm going to change, this is just in my way a little bit, so I have to make it zoom in a little more. Okay, so then from here, maybe I want to put in the number 1. So 1 plus what would equal 5? So you should be able to see that that would be a 4. 1 plus 4 would give you 5, or solve that equation. So there's 2 points on that line. So let's look at the other one, x, y, and this is just an H chart. I like it because then I can show you my work in the middle. So this one was 4x plus y equals 5, and this one's for 2x minus y equals 4. So if I put in 0 for x, 0 times 2 is 0, so you'd have 0 minus y equals 4. Well, the 0 doesn't affect it, but you can't leave it negative y equals 4. So I would have to divide by negative 1 on both sides to give me y equals negative 4. So when I put in 0, I got out negative 4. Let's put in one other number here, maybe 1. 1 will work. So you'd have 2 times 1, or 2 minus y equals 4. So again, solve this. So minus the 2 over to the 4. So you have negative y equals 2. And I am running out of room on my paper. So if I divide by negative 1, I'm going to get negative 2. So let's graph those. Now I'll use a ruler this time so my graph doesn't look quite as crappy as my first one. So 0, 5. So 0, 1, 2, 3, 4, 5 is about here. It's the point 0.05. And the point 1,4 is about here. And let's draw a line between those. And 0, negative 4, 1, 2, 3, 4 is here, and 1, negative 2 is here. I didn't label those, but okay, so there is my graph. Here's what, if I would have used graph paper, it would have been a little bit better, but where does it look like it's crossing here? It looks like what, maybe 3, 2? Around there. That's where mine looks. And the actual answer is 3, 2. Wow, mine is, I didn't know the real answer, so I just peeked over. So they really do cross at the point 3, 2. It's hard to tell on a graph exactly where they cross. If you use a graphing calculator, it does give you the exact spot that they cross. So if you have access to one, there's one in the high school textbook. For college, you'd have to have bought one. So it depends on where you're at. So this method is great. It's great if they cross at a specific point like 3, 2. It's also great if you're using technology to help you graph it. Otherwise, I don't like this solution in general, or this way of finding the answer. So remember, there's always ways to find your answer. This is just one. It's called graphing. I am going to show you one other graphing one, mostly because I want you to recognize when something doesn't have a solution. So here's my system of equations, and it doesn't matter whether you have function notation of the f of x or if you use y's. It's still a system of equations, same as if it has x's and y's in it. Okay, so if I look at this one, do you notice the slopes are the same? That's the number in front of the x. And if two lines have the same slope, what kind of lines are they? They're parallel. So let's look again at our little chart and put in some numbers. So let's look at y equals 3x first, and let's put in 0. Well, 3 times 0 would give us 0. Let's put in 1. So we'd have 3 times 1, so we'd get out 3. There's at least 2 points for that first one. Let's look at our second one here, which is y equals 3x minus 1. If I put in 0, I would get 3 times 0 minus 1. 3 times 0 is 0. 0 minus 1 is negative 1. Maybe I put in 1, so then I'd have y equals 3 times 1 minus 1. Start with your times, so 3 times 1 is 3. 3 minus 1 is 2. So here's our points of our line. Let's go over here and draw them. And see, we're always looking for where they cross. Here's our x, here's our y. So 0, 0, and 1, 3 is about here. And then 0, negative 1, and 1, 2. Okay. So 0, 0, and 1, 3. 0, 0, and 1, 3 are here. Then we have negative 1 and 1. I didn't draw that super well, but okay. I didn't draw this point here really good, but that's okay. You can see that those are parallel. They're really close together, so it's easy to mess that up. But anyway, when you graph it and they don't cross, if you don't graph it perfect, right, then it's going to look like it crosses even though it's parallel. This one really has no solution. If it asks if it's consistent or inconsistent, you would say inconsistent. That means there's no answer. It doesn't work. If you're doing a business problem, which these really do relate to a lot of business problems, you're going to end up with that not being a possible solution. Okay, so let's move on to my next method. That's called substitution. All right, so substitution method is kind of like, I want to find where they cross, but man, I don't want to have to use those graphs and try to guess. And what if it crosses at 3.5 and 4 2/4? You can't see that very good. Well, 2/4 is 1/2, so that's kind of a silly thing to say, but you can't see that very good. So we have to have another way to solve these. So I'm going to solve by substitution. Here's my first example. if I have y equals 4x plus 1 and I have 3x plus 2y equals 13. Okay, so here's my two equations. Now again, I could graph them. The substitution method is great if one of them is solved for y, like our top one. What I do is, if it's not solved for y or x, you can solve for x too. Then what you do is you solve for one of the letters and then put it into the other equation. So this method is great if one of them solved for y. If not, this method's not so good. Or if they're both solved for y or x. Maybe I'll show an example with x. I can't remember what my next example is. So what we want to think about is taking this and substituting it in here. Because when you're just looking at the equations, you're still trying to find where they're equal. So if you combine them and substitute them together, this better equal this y, so we can use the substitution method. So let me write this out. It would become 3x plus, keep the 2, take the y out, and in its place put the entire top part, equals 13. Then you have to go into solving your system or your equation here. So we leave the 3x plus 2 times 4x is 8x, 2 times 1 is 2. Simplify your left side by combining your like terms. So 8 and 3 become 11x plus 2 equals 13. So minus your 2 to get rid of the 2 by the x. And I would have 11x equals 11. Divide by 11 and you get that x is equal to 1. Once I know x, I go back to one of my original equations and I substitute x in to either one and find y. I like to substitute it into this one because I can easily see y by taking what we found, timesing by 4 and adding 1. You could still find it with the other equation because it better be where they're equal. You better get the same answer in both. So this one, y equals 4 times the 1 plus the 1. 4 times 1 is 4. 4 plus 1 is 5. So y is going to equal 5. So what's the point where they cross? They cross at 1, 5. That's the point where they cross without looking at a graph. Now could you graph them? Sure. The problem with graphing calculators is it has to be in the form y equals for both, so then it becomes hard on a calculator to check your answer as well. Okay, so then let's look at another one by substitution. Maybe let's see what I have on my example. I don't have another one on my example. That's what I was thinking. Let me look in the book that I'm looking at right now because I want to do one more of these. Ooh, there's a good one. What if I have x equals 5y and I have 5x minus 25y equals 5. So, oops, you can't see those, can you? So those are my two equations for my second example here. Set up perfectly for substitution again because it's one of them is solved for x or y. So I'm going to take this section here and put it in for x. So this is going to go here. So you still have this whole equation. So I still have this 5 times, instead of x, right, I'm putting in that 5y. I'm going to use a parenthesis. So it's just better because otherwise you mess this up. Okay, minus 25y equals 5. So again, you take out the x and you put in the whole other formula in that spot, or y, depending on which one. But on this one, it was x. Then 5 times 5 is 25. So you have 25y minus 25y equals 5. Okay, we simplify the left side and our y's are going to become 0. So you're going to have 0 equals 5. Is there ever a time that 0 will equal 5? No. So this is no solution. If we graph these, then they're actually parallel. Had I got 5 equals 5, that would have been many solutions or infinitely many solutions. So you have to be able to distinguish between something that's completely false, and if the numbers equal each other, then, or 0 equals 0, then you have many solutions. So be careful of that difference. So the last method is sometimes called elimination. I've heard it called linear combinations. I've heard it called the addition method. I was trying to think of what that other textbook called it. The method, this whole idea is called, it's like the idea of adding together your two equations and eliminating a letter. Okay, so this whole idea is to add them together. Hang on just a sec. I have someone calling me, so I'm going to pause this video. Okay, so we were starting elimination. So the whole idea of this is to add down. Let me show you an example because it doesn't make sense when I'm saying add it down until I've shown you what I mean. So I have 6x plus 5y equals negative 7, and I have negative 6x minus 11y equals 1. So let's say I just saw this system of equations. If I'm looking at my two methods, I would have to either graph them. Okay, but to graph them when they're in the form x, y number, that standard form is actually harder than if it's in the form y equals. So graphing would take us a long time. Can't put them in the graphing calculator because the y equals has to be there. And then from here, if I did substitution, I would have to solve for y or x on one of these. It will give me very, very ugly fractions. Then you have to add, subtract, multiply, and divide with fractions, which for some reason people tend to not like because they take forever. Then we have this third method, elimination, and this method is rockin'. What the idea is you add straight down and you get a 0. So let me show you what I mean. I'm going to pretend this is a big addition problem. That's why sometimes it's called addition. And I want the x's to eliminate or the y's or go to 0. See how 6x minus 6x is 0? That like we're going to add these two functions together. Positive 5 minus 11 is negative, I can't even think today, 6y. I was going to say 4, but I knew that was wrong. And then negative 7 minus or plus 1 is negative 6. So isn't that kind of cool? I can add those together, and that's showing they're equal. I already know they're equal, but it has to eliminate the x's or the y's, or you just formed another equation, and that's not going to work out very well for you. It can't have an x or a y. So then this is the same thing as negative 6y equals negative 6. So you divide by negative 6 on both sides, and you know that y is positive 1. From here, go back to either equation. I like the top one because it doesn't seem to have as many negatives in it. So I'm going to go, okay, top one is 6x plus 5. I know y is 1 equals negative 7. So I just put the y equals 1 right here. So we know that 6x plus 5 equals negative 7. Subtract your 5 over. And 6x equals negative minus more. Remember, you'd combine those and you get negative 12. You have to add them. Think of it as going more in the negative. Divide by 6 and x will equal negative 2. xy, so I would write that point xy. That's the point where they cross. So this method I love. I use it all the time when they're in the form xy number. This method is great. And let's say we got a problem like 4x plus 3y equals 1 and 3x plus 2y equals 2. So here's a problem that we got. If I got a problem like this, I cannot eliminate x's or y's the way they're written, right? X, 4 and 3 don't make 0. 3 and 2 don't make 0. So I can actually multiply an entire row by a number in order to set it up to be in an elimination problem. So we can set up the x's to eliminate or the y's. Because I used the x's the first time, I don't want you to think you always have to use the x's, so let's use the y's. Basically, I need this number to be the same as this number and 1 to be the opposite sign. So think about it. If this was if I took the 3 and I multiplied it by 2, I could get 6. If I took the 2 and multiplied it by 3, I could get a 6. But I need one of them to be a negative. So let's look at that idea. I'm going to multiply that entire equation by negative 2. I'm going to multiply this entire equation by 3. And you could have switched which one was negative, doesn't matter. Now watch how I do this. Negative 2 has to be multiplied by everything to make it a legal move in an equation. Negative 2 times 4 is negative 8x. Negative 2 times positive 3 is negative 6y. Negative 2 times 1 is negative 2. Switch to the bottom one. 3 times 3 is 9x. 3 times 2 is 6y. 3 times 2 is 6. So here's our second equation. Make it our big addition problem. And negative 8 and 9 make 1x or x. These ones eliminate to 0, which is what we wanted, equals negative 2 plus 6 gives you 4. X equals 4. Already got our answer there. Now, go back to one of your originals. I'll just use the top one and put that x in. So we would have 4 times 4 plus 3y equals 1. 4 times 4 is 16. Okay, then I subtract the 16 over. I'll have to continue it kind of over here. So minus your 16 to both sides, and I would get 3y equals negative 15. 1 minus 16 is negative 15. Divide by 3, and y will give you negative 5. Okay, so your points, or your two values are 4 and negative 5. I could write that as the point 4, negative 5. That's where those two lines cross. So if something's not set up for elimination, well then set it up. So you can multiply top and bottom. You could multiply just one row. Okay, before I end this video, I want to show one. I've just got a book of problems. This goes with one of my textbooks for college. And I just want to kind of show some problems over here. Let's look at like 19 here. Which method should I use for 19 if one of them solved for y? Or 20? Right? Do you see how one of them solved for y? I would use substitution. Now look at 23. What method do you think I should use for 23? Not substitution, because neither one is solved for x or y. I would want to use elimination because those x's go to 0. Look over here at 24. What method do you think you should use for 24? You could use either one, substitution or elimination. It really is set up for elimination. But you could easily subtract the 2y over and not get fractions and be able to use substitution. And that might make more sense for some of you. Okay, down here, 26 is not set up for either one. It goes x, y number, 4x, y. So you would probably need to divide everything by negative 1 to get the y by itself and use substitution. Okay, so just look at the problem before you start and think through. I don't care if the problem tells you to use substitution. I don't care if it tells you to use elimination. You can use whatever method works for your brain, but graphing is not consistent. You won't be able to come up with 10/3 for a solution. So graphing only on the ones it tells you to graph because they're pretty answers. Otherwise, use substitution or elimination. Okay, so that ends this video. Right.